Miss Higgins, how are you?
I'm good.
Good,
I'm
good, good.
in my hotel room in the mountains.
Oh, nice, nice, nice,
I
nice.
had sent you an email that I'm out of town this weekend, but
Yeah, yeah, thank you for that heads up. Um, so today we're going to be doing crosstabs and Chi Square. And Chi Square is really the first time that you're going to be able to form hypotheses and start to ask questions of your data. You'll start being able to make, distinctions and seeing if there's relationships. And really, what chi-square is asking you if there's a relationship between two categorical variables, all right? This is just a personal reminder to myself to start the resume recording. I realized last time that I didn't start it on time, so I'm going to roll on that. We're going to be doing assignment review. And I'm not just saying this, but I'm really, really proud of how well you all did and how creative you were with your assignments. You took something that I assume was new to you, and you were very thoughtful, and you all did a really good job collectively. And so I'm very excited. It was kind of hard to pick a best one, but they were great. Go ahead and prepare yourself if you're chosen in the next couple of slides. I want you to be prepared to sort of, I'm going to share the screen with you and allow you to present your either your scenario or your visualization. I want you to be able to explain it to the class. But again, very good job. So we'll be talking about, we'll be going over to our assignment, answering any questions there. We're going to review measures of dispersion. We'll spend a little bit, a pretty good amount of time. And then we're going to do an introduction into crosstabs. A crosstabs is sort of the precursor to chi-square. Crap. And we, it's really it's summarizing your data, your two categorical variables, whether it's nominal or ordinal. So we'll be going through that, and that's why we spend a lot of time on categorization of what kind of variables measures what kind of variables you were dealing with, because it does matter when we start getting into statistics or descriptive statistics or inferential statistics. There's certain things that you're able to do. There are certain effect sizes that you'll need to be able to use or to do to be able to measure the outcomes in your model. So it's like a whole bunch of numbers. So we'll be using 3 data sets today. We'll be using data set 4, college students coded. We'll be using, and be sure to use the coded version, not just the regular one. We'll be using data set 8, car sales, and bank loan. But before we get in that, I like to have our human moments and sort of open it up to everybody and ask them, how was your Labor Day? What did you do? Anything fun? Anything exciting? Did you go to a cookout and have some food? Talk to us.
I went to Charleston to visit my oldest daughter. She's in school there, so just wanted to go spend the weekend with her.
It's wonderful. That was really beautiful weather. Yeah, it was really, really gorgeous weather. I enjoyed it. Kind of didn't do too much, but yeah, it was pretty awesome. Pretty awesome.
I went to Wilmington and visited my oldest daughter, so I followed LaShonda.
Okay. Is she at UNCW?
Yeah, she's about to graduate in December, and she just recently got a house right outside of Wilmington, so I went and visited her.
Nice. That's excellent. Excellent. Anybody else?
I
All
went to
right.
a cookout.
Cookout. Uh-oh. Okay, what'd you cook?
I went.
Oh, okay. Well, you know, now folk hit me up and tell me to come to cookouts, and I have to cook. So, you know, it's
Nah, I try to make those.
my family members don't do me right. But it's all good. It's all good. It's all love. Birthdays, anniversaries, celebrations. So September is my month. This month will be my wife and I will be celebrating 12 years of marriage. I tricked her into marrying me, and she's hung along there for 12 years, and I tricked her into having 3 kids, and so it's just it's been a period of deception and coercion. So I'm very thankful that we've made it thus far. I hope we have many more. But yes, fall is a special time in my life, and just really really happy. My parents also got married in September, and so they've been a wonderful example for us. Anyone else?
Okay, I want to know what you're getting her for your 12th anniversary.
Yeah. Another kid. I'm kidding. Look, we old.
Wow.
We are old, boy. I've had one of my line brothers is joking with his wife. He's trying to convince her. He's the same age as I am to have another kid. I'm like, look, bro, I'm 40. Yeah, and getting up in the morning's different now, man. So you got to get up all times of night. Think about this, bro. So, but yeah, no, I got some things planned. Got some things planned for us, so we'll figure that out.
So yesterday was my 42nd birthday. Thank you.
Yay, happy birthday.
Happy birthday.
And birthdays are huge for me. Like I enjoy my birthday. I usually take the day off. Couldn't yesterday, but I enjoy my birthday. So, yep.
Maurice isn't with us to sing you the happy birthday, so we go ahead.
Okay. No, it's okay. We're all good. I got it sent to me in a text yesterday. I'm good.
That's what's up. Oh man. Anybody else?
My son's birthday is the 23rd of this month.
23rd. Okay. That's a blessing. Awesome. Okay. All right. We'll jump into the assignment review again. Thank you for your input, and I'll be following up with folks who had questions afterwards. After class. But as I promised, I would pick someone who had the best scenario and someone who had the best visualization. And this was not easy. So the best scenario award goes to and the recipient of the 5 extra points for that part of the assignment goes to Angela Hill. You did a really good job. I thought it was very compelling. It was able to sort of run right, and it had a good narrative hook, I thought. And one thing that I used to assess it is whether or not I'm interested. If the narrative is interesting enough for me to want to actually answer the questions, like I want to figure this out. And so I thought she did an excellent job. So, Mrs. Hill, do you mind taking the screen and sharing your screen and sort of going through your question?
So here's the problem.
All right.
I did not. Well, let me see if I can pull it up. Okay.
Now I can pull it up, and I can.
Oh, perfect.
I can walk it through.
There you go. That would be great.
All right, there it is.
Okay, so you just want me to share the scenario?
Yeah, share the scenario and sort of walk us through the data. And is this large enough for everybody? I can make it bigger if necessary.
Bigger
Alright.
the better.
Yeah,
Bigger is better. Okay,
bigger would be better.
let's do that then.
Clearly, I need to find my glasses.
It's all good. It's all good. Okay.
All right, so what I did was I did a Google search for data sets because I wanted something that was already for SSIP. I wanted it already done. So I did a search, and my first teaching job was in Chapel Hill. And so I knew that the Franklin Graham organization worked a lot with UNC Chapel Hill doing studies on education. So I pulled that information, and it was a project that they were doing with high-risk students, as far as before they entered kindergarten, they were at high risk of being behind.
Mhm.
And so I pulled part of that study, and it was a survey. And so what I was thinking about was like, you're part of an administrative team, and your principal or the superintendent basically is asked, don't just meet the academic needs of your students, but family members' needs as well. And so they suggested that you focus on kids enrolling in the school next year into kindergarten. So I used the neighboring research. So I'm placing myself in that Chapel Hill area.
Mhm.
And there's a large population of students coming in that have been identified for being high risk for developmental delays and school failures. And so most of the time, a lot of schools focus on the academic interventions, but my concentration in undergrad was on child development and family relations. So I have a big, I really feel like schools, we have to meet a lot of different needs. And so this superintendent's asking you to meet the needs and interventions and supports for caregivers as part of a different intervention for these students. And so the team has been charged with having interventions in the areas from the parents sampled that has demonstrated that they've had the most stress in certain areas.
Okay. Mhm.
And so I pulled the data set, and it already had the different groups, but the part I focused on was the relationship of parent to the subject.
Mhm.
And then it had, I think, 18 to 20 questions, and you'll see them listed there, and it went through different problems.
Mhm.
And so that was the information that was already there. And once you plugged it in, it just popped out. So I'm just glad I was able to find the information. And I mean, I don't know if this is the place to say it, but I think a lot of times we, as educators, think we know what stresses parents out because we're parents. Some of us are parents, or we think we know the families we're working with. And so looking at this information, some of the things that I thought would have stressed them out wasn't the highest, wasn't the highest things. And so I think a lot of times we miss the mark as leaders and educational professionals because we assume a lot without having the right data.
Right.
And so they really weren't focused as much on how their children were doing in school.
Right.
And I think a lot of times our first focus, I'm guilty of it, is like, I know how important academics are, so I'm trying to teach you about students reading and the importance of that every night, but they're more focused on problems in their marriage or things
Right.
like that.
Right. That is, from a psychoanalytical perspective, that is fascinating. And I wonder how that squares with other things. But this was just a fascinating data set. And you did a really good job of, these questions. How many parents participated in the project? 108. That's a great sample size. If you were to do some, if you were to do some inferential statistics, that sample size would be sufficient to give you, statistical significance. Yeah. So give us, I'm going to ask you a couple of questions. Yeah, I'm going to make you earn your 5 points.
Okay.
But no, it's cool. It's their anecdotal question. So why do you think the stressor situation that was not most often answered in the project was owing money or getting credit. Why do you think that was the case? Particularly because I'm assuming that this was an anonymous, you know, that you folk didn't have to put their names, you know, when you were asking these questions.
Right. I still think even if it's anonymous, I think people are not always trusting of others when it comes to things like money,
Right.
or getting credit. And I'm kind of familiar with that area, but to me, I assume that when a university or anybody's asking you questions like this, that's just something that they might not be proud of, or it might be something where it didn't bother those few that didn't. It wasn't a huge number that didn't, but it was the stressor that was most often not answered. But I think if I'm remembering correctly, that's also the stressor that was the most frequent or the highest, as far as owing money and getting credit. And one of my other questions, I think that was it. But I mean, I think it could be either way, but I think when people are thinking about, this is about my kid, and maybe it might trace back to me, or I don't even like talking about money. I know I don't. I don't like to even look at my credit card statement. I just keep paying it off.
Yeah, for sure.
Trying to pay it off. And so I think it's just something that people avoid a lot when they talk about money. So
for sure.
But it's something that they need education in. And so I think I wouldn't naturally think, oh, well, maybe I should get someone to come in and talk to my families about that and building a legacy. And my sorority's doing that, and I can see that people want to know about it.
Right.
But I just don't think that we usually cross those things in education.
No, that's right. That's right. That's right. Maurice, welcome, man. Hope you're doing well. So question 2, and this is for the whole class. I hope everyone can see. What statistic or what measure does the second part of that question represent? Mean, medium, mode, maximum, minimum. Which one?
What relationship a parent to subject or mode?
That's right. Absolutely. Because we're looking for what? The
Occurrences or frequencies.
Right. That's absolutely right. So I probably should have said frequency statistic that we see there most often. All right. Talk to us about number 6, Mrs. Hill.
So I went to that one because, like I said, I really think we focus a lot there. And so we start with that in schools, and we might not get as much of as much participation as we would wish. So when looking at this set of data, 66.6 parents were not at all bothered or a little bothered with how well their student was doing in school. So that wasn't a stressor for them. And so I feel like if we could start with something that was more on their priority list and then move to that, maybe tie that into what we're trying to do, we could sell what we're trying to sell. So I just thought that was really a big, I don't like that number sequence, but.
I don't either, but it's all good. But you had a dot there. You have a dot, so
no, that stops it.
That stops it. Right.
But I really thought that was huge, and and I really did this personally too, just because I really think that piece is the part that we keep missing. It's not about how many people show up. It's about how many people are engaged and change their actions based off of what we provide to them in trainings.
Yeah. Well, thank you. You did an incredible job. I can tell that this was something that you were interested in. And when you are doing research and doing statistics around things that you're interested in, generally it comes out in the quality of work. So incredible job. The next step in this, and one of the things I want us to be able all to arrive at by the end of this course, is being able to take these questions that you just answered and being able to write them up in an analytical perspective, in sort of You can tell a story basically from these numbers, and that's what we all want to be able to do. Compelling story, so you can basically say, as a researcher, I thought that these were going to be the things that I would get out of these questions, but in actuality, this is what came from the data, and this is what it suggests. And so all of us should be doing that, thinking about how to do that as we are doing statistics. It's not enough to be able to do the math problem, but it's also telling the story behind the math, because the math is just representative of society or the group that we're dealing with. And in this case, it's educational leaders. It's the work that you're doing every day. So again, wonderful job. Let's move on back to the best. Let's do the best visualization. That was very tough, and I'm gonna have we have a tie here. LaShonda Carver Moore and Maurice Mathis, two wonderful visualization. You see what, Maurice?
I didn't. Yay!
Yeah, you didn't like yours. No, I think that took a lot. That's not an easy visualization to do.
Right.
So I wanted to definitely give you a shout out for attempting that. That's not easy. It's a lot of data entry, and so definitely wanted to give you a shout out. But Mrs. Moore, Carver Moore, that this is great, and I want to show everybody yours. Let me get to yours as well, Maurice. I'm going to be showing off your other stuff, so forgive me. Copy. Yeah. So we're going to paste it. I'm going to show yours first, Mrs. Moore, Carver Moore. Okay. This is great. Talk to us a little bit about this first map, and maybe you found out that I'm a sucker for maps.
I didn't know.
Oh, I love maps. Love maps. But not only did you did a good job, doing the map, you also have it highlighted, each state highlighted, so that you have a pop-up. So this took a lot of time, a lot of thought, and it's very clear and very.
Oh, don't show mine after this. Just give LaShonda the points.
No. I'm going to show yours. This is good. Yours is good. You put the work into it. All right, talk to us, LaShonda.
Well, the actual study was trying to see if teacher expenditures, student-teacher ratio, and I'm trying to remember what the other one is, if it actually made a difference with SAT scores. And so when you really look at it for this one, North Dakota had the highest SAT score of 1,100 right there.
So let's stop there. That's very, very, very good description. Say again those factors. Start over again. You said what had an effect on what?
Trying to see if student expenditures, teacher salary, and there was one more. I just had it in my head. I cannot remember the other one.
It's fine.
But if it had an effect on SAT scores, so when you look at it, it looks like the highest SAT scores are really clumped in one area a little bit. Mm-hmm. But with North Dakota having the highest, so what I was looking to see if what do they pay teachers? What is the student-teacher ratio? What is the expenditure rate for students, to see if it made a difference? So I was going to leave it at this map and just do this one, but then I said, let me look and see if I can see the difference. So when you go to the next one, and South Carolina has the lowest.
5 pages.
She did her thing.
She
did her thing. Yo, she did her thing. I was like, yo, this needs to be written up. So I want to go back because I want to ask a question to the class, a very general question. So she said some very key words here. As a statistician, when you leave this class, you should be able to hear them and break them down. So she said teacher expenditure, student-to-teacher ratio. Is that right?
Student-teacher ratio
had an effect on SAT scores. So what are the dependent what are the independent variables here?
Are you asking me?
The whole class.
Student expenditures,
Student expenditure.
salary,
Salary.
and student-teacher ratio,
Absolutely. You're having an effect on what? What's your dependent variable?
SAT scores.
SAT scores. So what kind of variable is salary? If you have zero salary, you got zero salary. True zero.
Continuous.
Continuous, and what level of measurement?
Is it scale?
Ratio or interval? Which one?
Ratio.
Ratio. That's right. This is true zero. Teacher ratios, teacher student ratio. Y'all have to forgive me with this terminology. I'm not a true educator. What kind of variable is that? Categorical or continuous?
That one's hard because it has.
Repeat that again.
Your ratio, your student teacher ratio. That is also continuous, because I believe you can have a true zero there.
Well, like teachers, 0 students.
I guess you could have. I suppose if I'm thinking about this variable right, that you can actually have 0 teachers to 0 students. I assume. Let's actually skip that one without me having a full knowledge on what kind of what that's actually measuring. Now SAT though, SAT, that is I'm gonna go ahead and tell you that's your dependent variable, and it is continuous. But what level of measurement? Is it ratio or interval?
Interval.
That's right. Why?
You don't have a true 0.
That's right. If you get a 0 on your SAT, that does not indicate a level of 0 intelligence or 0 knowledge. It just means it's just an arbitrary 0. Absolutely right.
You also can't get a 0.
Yeah. Right. So you can see, and the question that Mrs. Moore asked was a inferential statistical question, and it'll be one of the main statistics that we cover this year, and correlation. So she's asking, do these 1, 2, 3 independent variables have an impact on SAT scores? And so since she has a sample size, what will her sample size be? What will her unit of analysis be? Let me ask you that question first. Let's break this down. What is the unit of analysis? What is her sample size? And Ms. Moore, you can jump in here.
The number of states.
That's absolutely right. Absolutely right. 50. The state is your unit of analysis, because that's what we're analyzing. That's what we're looking. We're looking at each state's, variable as it relates to SAT scores, as it relates.
I used to think there were 52 states. And by used to, I'm like, sometimes I still think there are 52 states.
Yeah. So,
It's not held me back from life though. I'm still in my doctoral program.
we're still here. I'm not going to tell you some of the things that I thought growing up. Well into college. So, okay, Mrs. Moore, let me let you take over again. That was, I'll go back to page 2. I just wanted to break this down, but since these are all, all of your variables are continuous, you would use a certain kind of inferential statistic, being correlation, and then you can really get into, if you want to start the predicting, what kind of impact those 2 variables had or 3 variables have on SAT scores, or you want to see how much does ratio have an impact on SAT scores relative to teacher salary, you can do that in what's called regression. Have anyone heard of regression? Yes,
In
regression.
psychological terms, not statistical.
Yes, we're going to be doing regression. And that's my favorite statistic of all. So yeah, that we'll be getting into all of that. Just want to give you a precursor. I want you to be thinking through as she's talking how this breaks down. Okay. All right, let's go on. I'm sorry to interrupt you. I won't interrupt you anymore. You take it from here.
Okay, I hope I can keep going. For students, and I'm focusing on North Dakota, South Carolina, because I know they are, the minimum and the maximum of the scores. So when I look at North Dakota here, they have a low student teacher ratio. So, but if you also go to South Carolina, they also have a low, that's South Carolina, go back down one more.
Oh yeah, sorry.
They also have a low ratio as well, but the comparison of the scores are on, they're two different spectrums of it. So with that, it just makes me think that student teacher ratio really doesn't make a difference, because North Dakota scored highest and South Carolina was at the lowest.
And that's something that you'll be able to tease out in a Pearson correlation matrix. You'll be able to see, what kind of relationship exists between SAT scores and ratio versus maybe what relationship exists between salary and SAT scores, and so on and so forth.
Mm-hmm. And then even if you look at, the upper, like in New York,
yes.
Later as we keep going, you'll notice that the salary is high for the teachers. The ratio is low, but the scores are low. So it's everywhere for this. So it's really difficult to pinpoint to say that actually any of these things are relevant or correlational to the SAT scores.
Sure. The fluctuation in SAT scores, is called variance. And so one of the things that you'll want to do is measure how much of an impact each of these variables have on the variance in these SAT scores. And some of these variables that you've identified will have, a significant beta score, or it will tell you that salary does have an impact, may have an impact. But you may end up putting together a model where it doesn't tell you, or it doesn't prove that any of the variables that you have identified have a huge impact. It may only explain 20 or 25% of the variance in that in SAT scores. At which point you have to ask yourself as a researcher, are there other variables not captured in this data set that are having an impact on SAT scores? And I can guarantee you, in New York, there are probably a lot of other factors that are influencing SAT scores, and probably in other places as well. All that can be mathematically expressed, and looking forward to having that lecture in a couple of weeks, just to show you the power of correlation matched with regression. Those can be those are very powerful dissertations and studies, should you be interested in that. All right. Did you want to show any more of your number 3? Oh, here's expenditures. Yeah, expenditures in relationship to SAT scores. So it appears that New York has.
They spend the most on their children.
Yeah,
yeah, they spend a lot. And if you look down south.
Yeah, not so much.
Not so much. Yeah. So it's a big difference when you start to look at the per pupil expenditures that they have. And then the very last one, I think, is teacher salary. And that's low everywhere, except up north. And again, it does not really match the SAT scores like before. And you'll see it in the larger places like California, they're moderate. Hawaii over there, you got Alaska, all those places. Well, I don't have that one, but they're all up there and they do really well.
It's interesting. And
that might also be because of I don't know if it would be beneficial to add an independent variable of which states have teacher unionization, because coming from California where there was a union and then moving here to North Carolina, it was very evident the differences between not just salary, but the the work environment that teachers have in union and versus non-union states. Just sorry, didn't mean to
No,
interrupt.
I love it.
Makes
I,
sense.
for fear of getting into my politics, I'm a big fan of unions, and I work in a. I belong to a union, and my wife is a teacher, and she doesn't belong to a union, and some of just the differences, we have similar levels of education, and this is how you're treated in general is just. She worked very hard to get her advanced degrees, and as did I. And we're just at, similar points in our career, and just the way we're being treated is just incredible, particularly in this pandemic. So it definitely has it has an impact on the way folk are treated. And I believe it has impact on outcomes as well. So here is a frequency bar chart. I thought you did a pretty good job. I think in terms of just some feedback, you may want to omit, values that far exceed so that it will better represent or better display the others.
And I was going to put on a separate one, but I was tired. So I said, let me just put it on this one.
You did your thing. You did your thing. All right, I'm going to go over here to Maurice. His seemed to capture SAT scores. SAT seemed to be the topic du jour today. But yeah, let's talk about that, Maurice.
Yeah, I'd like to defer all my points to LaShonda because hers was truly amazing. So what I did was I was looking at, I used the same data set for both parts of the question. So I think it's good to quickly talk about my first question, which the scenario was you're interviewing for the assistant superintendent of like instruction or something like that, and you are looking at the two largest districts thank you. You are in the final interview stages for the Assistant Superintendent of Research and Analysis for NCDPI. The hiring committee has presented you with SAT scores for the schools in the two largest school systems of the state. The most recent school year for which these schools represent was the first time a statewide standardized SAT test preparation was instituted. You've been tasked with analyzing the data between the two systems to determine if they should continue with the statewide test preparation initiative. So really, I literally just have test scores by school and then by district. So what the Flourish model represents is what it tries to show is, and it's not on a continuum, but I still wanted to give some visualization or movement to it. So it ends up showing that I think Wake County Schools overall has a higher average student SAT score than Charlotte Meck.
Mm-hmm. And it does that quite well. You see where it starts, where the visualization starts out. Charlotte Meck catches it obviously, and then it flips back as the graph goes gets higher as the SAT scores get higher. So yeah, very, very, very big fan of this kind of visualization. Again, data is great. Data analysis is great, but I think being able to tell the story, as so many of you have been able to do in this assignment, is really the next step. So, like I said, it's fine to do the math, but be able to tell the story behind it as well. All right. All right. Thank you all for your hard work. We're going to jump into measures of dispersion. And so we talked about what variance is. It is the average of the squares of the deviation from the mean. We went through that. Formula yesterday. Well, not yesterday. Wow, 2 weeks ago. It indicates how far individuals in a group are spread out. It's pretty much just a raw form of that. Again, the variance is defined as the average of squared differences from the mean. And to do that, you work out what the mean is initially, and then for each number or each observation, you subtract that number from the mean and then square the results. And you square it because you want all of your values to be positive. All right, so what does variance answer in turn? It answers, it says, what is the variability of values around the mean? What is the size of the data spread? How far are individuals in a group spread out? And then it generally tells you, what are your outliers? You can use continuous or scale variables. And I had a sample problem here. If you plug these numbers into SPSS and are able to do this, if you're able to plug these numbers into SPSS, we will see that the standard point spread should be, I think, 399. Let's try that out real quick. All right, so let's fire up SPSS real quick, and we're going to do a new data set here. So just fire up your SPSS and get it looking like this. Can everyone see my screen here?
Yes, sir.
All right.
Yes.
So let's go ahead and put in these numbers. Just say 45, 57, 68, 78, 88, 93, and 100. And what we're going to do, we're going to...
Dr. Munn, can you push pause right quick?
For sure.
For us who are a little bit slower. All right, 45, 57, 68. Variable name contains, because I'm supposed to be in data view. Okay. I'm supposed to be in data view?
Yeah, data view. It should look like an Excel sheet.
All right.
Now we're basically walking through and figuring out how to get the variance. And you can do this in any data set that has scale or continuous data. You won't use variance very much in analysis, but I do want to show you how to do this. And obviously this lecture is recorded, so you can go back and review it if you have questions about how to get it. All right, is everyone pretty good here? Let's go to variable view and let's go to name, and let's just change this to test underscore scores, okay? Now you have to have underscore because SPSS does not like spaces in your variable name. Let's go to label. Now label says tests can have spaces and so forth. Test scores parentheses 1. Okay. Then we're going to go over here, and you don't have to do this, but we know that this is not an ordinal or nominal variable. So we're going to make sure that that says scale. Generally, you can do the analysis without having to do this. But if you're building your own data sets from hand, or you're pulling in data from different places, and you're wanting to build your own data set for your dissertation or for your study or for your article, it's best on the front end to do the work, because it will save you time and steps on the back end. So once we have put name in here and we've labeled it whatever we want to label for our own edification, then we go and we've done we've changed the measure to scale. Let's go back to data view, and we see here where our variable has a nice name, and it has this little scale icon here that tells us that this is a scale or a continuous variable. So now, in order for us to get the variance, we're going to go to Analyze. We're going to go to Descriptive Statistics. We're going to go over to Descriptives, and we're going to put that variable over here in this box. Okay? Then we're going to click Options, and we're going to uncheck everything except variance. And we're going to click Continue. And then we're going to click OK. And your output should put out something that looks like this, 399.6. Okay? Is that what everyone got?
Yes, sir.
Great. Great, 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 great.
I did something wrong.
Okay, let's go through it.
I have 45, 57, 68. I have the correct numbers under the test score.
Mm-hmm.
Analyze,
Mm-hmm.
descriptive statistics,
Mm-hmm.
frequencies.
No. You analyze descriptive statistics, descriptives.
Oh, and then I said the wrong thing. And then I put the test score over there for the variable. I clicked options.
Mm-hmm. And then you click variance.
And uncheck everything else.
Yes, ma'am.
I forgot to uncheck everything else.
And then you click continue. And then you click OK.
Okay.
All right, Ms. Simons, what is our N?
Seven.
All right, we have seven test scores here. Good. Great, cool. So that's pretty easy. Just wanted to show you how to do that. So
wash your hands.
So we're going to go. It's okay. So we're going to talk about standard deviation, and basically it's the square root of the averages of the squares of the deviation for the mean. So in this case, it's the square root of 339.6, which I believe is like 19, I think. It's useful in expressing deviation from the mean in the same units of the data set. And it indicates how much observations of a data set differ from its mean. Yeah. So if you go back to the same data set, I think it's untitled. Great. Yep, there it is. If you go back to the same data set and you go to analyze and you go to descriptive statistics and you go to descriptives, basically going to the same thing, and you go to options, keep your variance checked and just check standard deviation. Let's go ahead and click mean as well. And then we're going to click continue. And then we're going to click OK. So we see some familiar stuff here. We see the mean that we had earlier in 75. We see, and if you take a calculator out and you take the square root of 399.619, you'll get 19.99047, which is your standard deviation. So each of these data, in my opinion, are pretty spread out. You go from 45, which is half of 100, all the way to 100. And so what this represents is a pretty spread out, pretty dispersed data set. Okay.
Dr. Munn, can you do that again for me, please?
Sure. The SPSS part?
Yes, sir.
Sure, happily. All right. So you have your same set of numbers here. And so all you do is go to Analyze. You go to Descriptive Statistics. And you go to Descriptives. And your variable should still be here in the box. You click Options. And then what you want to check is mean, standard deviation, and variance. You want to click Continue. And then you want to click OK. And so you're looking for your red arrow. You have your mean here. You have your number of observations. You have your standard deviation and your variance. Okay. Awesome.
Thank you, sir.
No problem. So we're going to watch a quick video here. I've found this video to be very helpful, helping me refresh. I don't use standard deviation every day. It's not my go-to statistic. So whenever I take a break from standard deviation and have to try to explain it, I like to use this video. This video I can link into the course notes or course materials, but it's a really good one. So I'm going to full screen this, and I'm going to hush and hope that this is loud enough for you all to hear it. If you can't hear it, interrupt me so that we can adjust the audio. Uh-oh. Could you all hear that?
Very well.
Good.
Have we discovered a new particle in physics? Is a manufacturing process out of control? What percentage of men are taller than LeBron James? How about taller than Yao Ming? All of these questions can be answered using the concept of standard deviation. For any set of data, the mean and standard deviation can be calculated. For example, 5 people may have the following amounts of money in their wallets: $21, $50, $62, $85, and $90. The mean is $61.60, and the standard deviation is $28.01. How much does the data vary from the average? Standard deviation is a measure of spread, that is, how spread out a set of data is. A low standard deviation tells us that the data is closely clustered around the mean, or average, while a high standard deviation indicates that the data is dispersed over a wider range of values. Standard deviation is used when the distribution of data is approximately normal, resembling a bell curve. Standard deviation is commonly used to understand whether a specific data point is standard and expected, or unusual and unexpected. Standard deviation is represented by the lowercase Greek letter sigma. A data point's distance from the mean can be measured by the number of standard deviations that it is above or below the mean. A data point that is beyond a certain number of standard deviations from the mean represents an outcome that is significantly above or below the average. This can be used to determine whether a result is statistically significant or part of expected variation, such as whether a bottle with an extra ounce of soda is to be expected or warrants further investigation into the production line. The 68, 95, 99.7 rule tells us that about 68% of the data fall within one standard deviation of the mean. About 95% of data fall within 2 standard deviations of the mean, and about 99.7% of data fall within 3 standard deviations of the mean. The average height of an American adult male is 5'10", with a standard deviation of 3 inches. Using the 68, 95, 99.7 rule, this means that 68% of American men are 5'10", plus or minus 3 inches. 95% of American men are 5'10", plus or minus 6 inches, and 99.7% of American men are 5'10", plus or minus 9 inches. So this means only about 0.3% of American men deviate more than 9 inches from the average, with 0.15% taller than 6'7" and 0.15% shorter than 5'1". This reasoning suggests that LeBron James is 1 in 2,500 and Yao Ming is 1 in 450 million. In particle physics, scientists have what are called 5 sigma results, results that are 5 standard deviations above or below the mean. A result that varies this much can signify a discovery, as it has only a 1 in 3.5 million chance that it is due to random fluctuation. In summary, standard deviation is a measure of spread. Along with the mean, the standard deviation allows us to determine whether a value is statistically significant or part of expected variation. Thanks for watching. See.
All right. Again, that I'll make that available for everyone as a refresher. It's always really good. So again, a 68, 95, 99.7 rule means that, you know, that any sort of thing that you're measuring and it has some normal distribution, 68% if it's salary, or if it's, height, weight, SAT scores, whatever, that will fall 68.27 generally fall within 1 standard deviation plus or minus the mean. So if your standard deviation for a classroom GPA or classroom SAT score is 50, then basically what that says is that 1 standard deviation, that's almost 70% of all of your SAT scores are going to fall within plus or minus 50 points of the mean or the average. So in 95% of all the scores, again, this is assuming we have a normal distribution of data, 95% of the scores are going to fall within 2 standard deviations. So 100 points plus or minus the mean. And 99.7 percent of all the scores will generally fall within 150 points plus or minus the mean. So it's a very fascinating rule. Here's just there's just a percentage breakdown. So you have a very, very small chance of being outside 3 standard deviations from the mean. So that brings us to range. Range is probably the easiest measure of dispersion. It's just the difference between the highest and lowest scores. I saw all of you handled that very well on your discussion boards. A discussion board, basically in this case, so can someone tell me what the range is? $55. And not to insult your intelligence, but just to show you how to do it, and SPSS will bring up this sample data set here again that we just created. We'll go to Analyze. We'll go to Descriptive Statistics. We'll do the same thing we did earlier. We'll go to Descriptives. We'll go to options and you'll see the checkbox for range. You'll click range, continue, okay. And it will show you that Maurice indeed is very good at math. And it is 55. All right. So we're gonna have some fun here. Who do I like? Who haven't I picked on today? Mr. Hernandez. Don't kick my daughter out of school. I want you to figure out. I want you to figure out what the mean is for the left set of data. And Mrs. Mitchell, I want you to figure out what the mean is for the right set of data. And this is why standard deviation matters. So we have these data categorized as a 9-year-old. Mariana's 10 now. So we're going to change that to 10. Allowance balance by dollars. So if you were like me and as a 10-year-old and mismanaged your money, you're always asking for an advance on your allowance.
And you were asking for the mean, right? Not the range?
The mean, yes, sir. The average, yes, sir.
Oh, so that would be 10?
That would be 10. All right, Miss Mitchell, tell me what the mean is for your set of data.
Dr. Ma, I have an emergency.
Oh, okay.
I'll text you guys. I'll be right back, though. It won't take long.
Okay, I'm very sorry. No problem.
I have the mean of the other set Tina was working on. It's 10.
It's 10. It's interesting, right? Now, I was a child on the left, and I was horribly irresponsible with my money. Your child might be more responsible, and this was their balance from week to week. But the average is 10 on both sides, right? And so it doesn't tell you very much. So let's plug these numbers here into SPSS. And so what we're going to do is let's go ahead and go to variable view. And let's put in child underscore child, not chid, underscore 1. And then we're going to put in child underscore 2. Okay. Then we'll go back to data view. Everybody catch that? All right, so we're in variable view. And we're going to put in child. We're in our name column. We're going to put child underscore 1. I'm going to put child underscore 2. All right. So we'll go back over here to data view, and you see these nice columns here that look like they're ready for input. So let's go ahead and put in the first line of data here. We'll go -10. We'll go 0. We'll go 10, 20, and 30. So they really earned their money very well they recovered their balance, and they're sitting at $30. All right. So for child 2, we'll go to 8, 9, 10, 11, and 12. And again, this is why standard deviation and spread is so important. Everyone let me know once you get to this point.
I'm good.
Okay. Everybody good? All right. So we're going to go to analyze descriptive statistics, descriptives. I'm going to show you a quick trick here. If you already have data in this box, you want to hit reset, and it clears everything out, and you can start over. Now, what we want to do is highlight these two, or double click however you'd like, and move both of those data points over, or both of those lines of data into variables, both of the variables in there. Okay. Once you have child 1 and child 2 in this box, you're going to click options, and we're going to click all of these. We're going to click mean. We're going to click standard deviation. We're going to click variance. We're going to click range. We're going to click minimum and maximum. Okay. So in total, you should have 6 boxes clicked. I'll just let it sit there for a while, let everyone catch up. We good? Okay. Click continue. And then, okay. Now, we see, although we have the same means, everything else is much different, okay? All right, so we see here that the range is what for child 1?
40.
Uh-huh. Minimum is -10. Maximum is what?
30.
Standard deviation is what? How many standard deviations from the mean?
15.8.
Let's put it in terms. What kind of units? Dollars, cents, pounds?
$15.
$15, yeah. And you can see the variance being much larger. Now, for child 2, the range is what?
4.
Minimum is what?
$8.
Mm-hmm. Maximum is $12.
Mhm.
Again, the mean's 10, it's the same, but we see the standard deviation is what?
$1.58.
$1.58.
$1.58. So what does that tell you about the spread of data here from child 1 to child 2?
Child 2 is more consistent, or
Yeah, so when you look at the mean, those values are going to be what? They're going to be much more bunched around the mean, right?
Mhm.
Versus child 2, who's just had this wild swing, and so the values and as indicated by the standard deviations, it's pretty wild. It's pretty spread out. Okay, so that's why that matters. That's why standard deviation matters. You can have a set of test scores. You can imagine you can have, a school where you have really high performing students and really low performing students, and the scores may average out, but it won't tell you the whole story until you sort of take a look at the standard deviation and spread. Does that make sense?
Yes.
Yes.
Okay. All right. Classroom heights example. Yeah, let's do this. This is cool. This is cool. All right. Can each of you in the chat put your name and dash your height in inches?
Height in inches. No, I need a calculator.
Yeah, look. All you gotta do, if you're 5 feet, if you're 5 feet 5, just hit 5 times 12. Yes, right. 5 times 12 plus the inch, plus the leftover, okay? And then you got it. There ain't nobody in here 4 feet, are they? I ain't picking at you.
You might have 1 or 2.
How did you say calculate that again?
So if you're 4 feet, say you're 4 feet.
No, no, I'm no. 5'10". How would you calculate that?
Yeah, so you would just multiply 5 times 12. That gives you your 60. That gives you your 5 foot, and you just add 10 inches. Does that make sense, y'all? I'm coming off my head with that. Okay, cool. All right, I have screwed up in math before, so.
You're not going to ask us to put our name and our weights in the chat. No.
Look, I have taught this class twice before and made that horrible mistake before, and we'll never do it again. The students were like, what's wrong with this dude? Oh, man. Lessons you learn. All right. Now remember your
tall ladies in this class. Y'all come on, ladies.
They ain't playing. They drink their milk.
Playing.
What'd you say, Maurice?
I said we have some tall ladies in this class.
Oh. Vonda is runway model tall. I think she probably did some catalog work in her youth.
All right, Vonda Martin Jenkins.
Okay, so I have, check my data here, 66, 69, 72, 66, 67, 71, 69, 71, 64, and 70. Great. All right, so these are our classroom heights. I'm just going to do sort of a very live version of standard deviation of spread here. So let's get into it. And if you all want to follow along, I'm gonna pause for a couple of seconds and let you jot this down so that you can do it as well. Do it with me. So I'll give you about 2 minutes to jot this down. Again, what I did is I went to variable view and I went ahead and put in classroom height. Yep. And then I just dropped these data points in there. All right, we good? Cool. All right, so we're going to go to do the analysis here. We're going to go to analyze. We're going to go to descriptives. We're going to go to the statistics, and then to descriptives. Let me not get ahead of myself. We're going to reset. I wonder why that made that a nominal variable. That's interesting. Hey, right. I'm going to go ahead and put classroom heights in there. We're going to go to options. We're going to click variance and range. So we should have mean, standard deviation, variance, range, minimum, and maximum checked. So you should have those 6 checked. I'm going to click continue and okay. Okay. So taking a look at this sample size, we have 10 people in the class at this point. All right. Our range is 8 what?
Eight inches.
8 inches. Okay.
I was muted, my bad. 8 inches, yes.
All right. Our minimum is 64, right? Maximum is 72. Our mean is 68. So our average height in this class is 68.5 inches. Standard deviation is 2.63 inches, and the variance is 6.9. So I wouldn't say that I would say that we're pretty closely aligned around the mean. Okay, so let's do this. Let's take the mean and let's subtract 2.6 and add 2.6 to the mean. Okay?
What am I gonna do about it?
So we're gonna take a piece of paper like this. And we're gonna write 6.85. And we're gonna add 2.6 to it, and then we're gonna subtract 2.6 from it.
Dr. Munn,
Mm-hmm.
Tina Mitchell asked us to let you know that she's listening and following along, but they've had some issue with the storm with their car, their vehicle, so that she's speaking with insurance people as well. So
Okay.
she just wanted you to know.
Yeah, I tell her I appreciate it. So
Can you repeat those steps? 6.85 plus 2.65, then subtract 2.65.
yeah, then subtract 2.65 from 68. So what we're trying to do is see what the range is for one standard deviation from the mean. And what I should have had hooked up today was my iPad, so I could have done the drawing. I could have done a bell curve, but in lieu of that, what we're going to do is we're going to add this together. And so 68.5, which is our mean, plus 2.6 is 71.1, okay? And then 68.5 minus 2.6 is 65.9. So if your height is between 65.9 inches and 71, say yes in the chat.
Can you ask that question again?
Yeah, so if your height is between 65.9 and 71 inches, put yes in the chat. 1, 2, 3, 4, 5. Wow. So 5 of you, 6. Hold on, make sure. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. That's incredible. Right. So 7 of you are within one standard deviation of the mean. Now, if we go back to our 68, 99, 95, and 99 rule, what does it say that 68% of would fall of the data set would fall under. It said 68% of your data set would fall within one standard deviation. This is like literally magic. Like, you know what I'm saying? It's really fascinating to do this. I mean, and it's consistent for every class because height is sort of a thing that's pretty standard once you get above, 5 or 6 entries. But true to form, 70% of the class falls within one standard deviation of the mean. If you're outside of that, who is? So I had one person that was 72 inches, right? And I assume there was someone who was a little lower as well. So that's 2 standard deviations from the mean. They probably fall within the 95, probably rounded out to 100. Is anyone's 3 standard deviations from the mean? I don't think so. And 3 standard deviations above the mean would be, let's see here, 2.6 times 3. So that would be 7.8 inches plus or minus 68.5 inches. So I don't think anyone is in the class is above 76 inches, right?
That's my brother.
Are you serious? Good gracious. And I don't think anyone.
78. He's 78. That boy is tall.
It was 76.3. 78 inches?
6'5". Yeah, he's 6'4".
Good gracious.
Oh boy.
And 65 minus 7.8 is 60 inches. 60.7 inches. And so that's right at 5 feet. But I think everybody cleared 5 feet, right? So cool. So yeah, so that's 3 standard deviations from the mean. Again, 1 standard deviation in this instance was 2.6 inches. And so everyone sort of falls within this bell curve. Okay, I always like doing that.
Dr. Munn, is this a good time for our break? It's almost 10:30, or do we need to start something new?
Let us finish. Let's do this. Let's open up our college students, and I want to basically finish standard deviation and measures of dispersion here. So let's fire up our college students data set. And we're going to look, we're going to get the standard deviation for English. Ms. Carver Moore, can you find the standard deviation for English? Mrs. Hill, can you find the standard deviation for sleep? And Philip, could you find the standard deviation for study? And I'll take the range for weight. I'll take a volunteer for that.
Dr. Munn.
Uh-huh.
I don't have a computer with SPSS. I'm out of town. Sorry.
Oh, okay. Gotcha.
Me too. I'm sorry. I was begging for you not to call on me because I'm just following along.
All right.
But I mean, if somebody did it, I can read it off. I mean, I just can't. I just don't have it on my computer.
I don't have SPSS on this laptop either.
Okay.
Dr. Munn?
Yes.
This is my battle assembly weekend, and I'm at the hospital doing my government physical.
Okay.
And I'm just listening in.
All right. So I'll just
jump in. Y'all can jump in. You can give me something, Dr. Munn.
Okay, cool. Let's do if you could do English and sleep. I'll do study and I'll do the range for weight. Okay.
English and sleep.
Yeah.
And what am I finding? The
standard deviation.
Okay.
Mm-hmm. And I'll just wait for you. Well, actually, I'll do it with you.
Wait, what am I doing?
You're doing a standard. You're doing a standard. You're going to find the standard deviation for English scores, and you're going to find a standard deviation for sleep hours. I think it's represented in hours, and that's from the college students. Should be coded.
Sleep time. Okay, I see it.
Mm-hmm.
Do we need the minimum and maximum or just the standard deviation?
Just a standard deviation.
I did the standard deviation for English. I think I got the right column. It's 6.83.
6.8.
I hope I pulled the right one up. Yeah.
I had English. I thought, but I don't know what I'm supposed to be. But I do have sleep.
Okay.
Well,
I have what LaShonda had.
6.83.
Mm-hmm.
Sweet. That's what I got. Very good.
Sleep time is 2.42.
Oh wow, that's a pretty big. Yeah, that's pretty darn dispersed. If you think about it, that means that people are basically, getting a lot of varied hours in sleep. All right, so we're gonna put sleep over here.
What's the meaning of sleep?
I was definitely team no sleep in college.
I'm team no sleep now.
Yo, you can't do it. I'm assuming you're over 30. Don't do it. Don't do it. It's not the move.
Fred, that's why I'm rocking so much. Fred texted me talking about you rocking like you on that stuff. I'm on that stuff of no sleep.
Oh goodness. 2.4 hours. Yeah, that's right. And then we had study time. So let's do that together real quick. We're gonna go to descriptive statistics, descriptives. We're gonna put study time over here. I'm gonna hit OK. And wow, that's a huge variance in terms, and that's hours. So a lot of dispersion in terms of how students study at this university. And let's do the range for weight. So we're gonna go from descriptives, we're gonna go to weight. We'll reset and then just put weight in here. We'll undo all of this, minimum, maximum, just do range. And the range for weight is, wow, 248. So you got obviously someone who weighs a lot versus someone who doesn't weigh very much at all. And that's pretty big. I should have left in minimum and maximum, excuse me for that, because that would have told us exactly what the height, the highest weight and the lowest weight. So the maximum weight was 350 pounds and the minimum was 100 pounds in college. Okay. All right, it is 10:31. I will see you guys back here at 10:41.
All right.
All right, everyone. Welcome back. So now that we're finished with our review, we're going to be moving into new territory today. We're going to be discussing z-scores, which is really the last frontier in terms of measures of dispersion. And then we're going to move into inferential statistics. We'll be getting into crosstabs and chi square. We're not going to jump too heavily into crosstabs and chi square. It's going to be sort of an introduction. We'll go deeper next week. But yeah, we're going to be talking a little bit about z-scores. All right. So the question is that z-scores answered is, what is the standard score that tells you how many standard deviations above or below the mean of a score falls? Okay, and it requires continuous variables. So if 45 to 100 in scores isn't relative, what are the standardized score range? So z-scores are basically decimals, and they tell you how many standard deviations. It's really a number that represents how many standard deviations your height or your salary or your whatever your measure is falls above and below a mean. And we're going to do that right now. Okay. So how many standard deviations is your raw score? How many standard deviations does a value lie above or below the mean? What is the standardized score of an empirical raw score? So instead of saying the standard deviation of whatever this data set is, say $5,000, we're going to say the standard deviation, the raw score for 68,000 happens to be this number of standard deviations above or below the mean. And I'm going to show you how to do that today. Okay, so I'm going to minimize this here. We're going to keep these values in our in view here. And so what we're going to do is go to variable view. And in variable view, row 5, we're going to put in first year biz student earnings. Okay. First year biz student earnings, and make sure to put an underscore between each of them. So these data points represent how much business students from Fayetteville State earn in their first year of business, having graduated from our illustrious MBA school. Okay. So once you've done that, I'm going to go ahead and put scale, because this is going to be a continuous variable, of course. And then we're going to go back to data view, and we're just going to drop these numbers in here. So we're going to go with 45,000. We're going to go with 57,000, 68,000, 78,000, 88,000, 93,000, and 100,000. All right. So let's just do the basic measures of dispersion, just to get an idea of how these data are spread. Okay. So we're going to go to Analyze. We're going to go to Descriptive Statistics. We're going to go to Descriptives. I'm going to reset here. And then we're going to take first year biz students earning and put it in the variable box. Let's do our normal 6 here. Our mean, standard dev, variance, range, standard deviation, variance, range, minimum, and maximum. And then click continue. And then we're going to click OK. Okay. So we have seven students who entered their data, and we have some pretty familiar stuff. Here. Our range is $55,000. Of course, our minimum, pretty familiar here, was $45,000. Our maximum was $100,000, and our average was what? What was our average salary for these 7 MBA graduates?
$75,571.
That's right. So what is our standard deviation?
It was $19,000, almost 20,000.
But that can be a handful to say, oh, $19,000 plus or minus $75,000. So here's a different way of representing these data. I'm going to show you a trick. Okay. So remember here we have first year biz student data. And we may want to, instead of saying, you know, these data points are fall within, you know, 1, 2, 3 standard deviations from the mean, or having to subtract or add 19,990 from $75,000, we can do this. So we want to represent these data points as z-scores. And it's not apparently, there's not a button that says z-score, but I'm going to show you how to do it.
Why not?
Yeah, SPSS. So we go to descriptive statistics, we go to descriptives, and we stop here and we say save standardized values as variables. So you click that, and then you click OK. And what you're going to see is Z, which represents z-scores. And then you're going to see first year biz students earnings. So what this tells us is that, again, the mean was what, $75,000? We see here that $45,000 falls how many standard deviations from the mean?
Wait a minute, Dr. Munn, can you go back over that so I can get the z-scores?
Sure, happily. So what you're going to do, let me see, I undo this. Oh, it won't let me do it. Okay. So what we're going to do is once you have your, once you've done your first analysis and you want to sort of standardize your scores, you want to make it something other than huge $19,990 and as a standard deviation unit, you can simplify it and you can just display these data points as individual standard deviations from the mean. And this is very useful for composite variables, which I'll get into in a couple of seconds. So we'll go to Analyze, we'll go to Descriptives, Statistics, we'll go to the Descriptives, and we'll click here where it says Save Standardized Values as Variables, okay? We'll click that, and then we'll just click OK. And what it's going to do, you know, I've done this twice, but what it's going to do is give us this column here that says Z or Z, first year biz student.
I have it.
Okay.
Okay.
So remember, we're going to go back here to our output, and we remember that our mean is $75,000. So that's your midpoint on your bell curve, right? So how far away on a bell curve do you think that $45,000 is from $75,000? Pretty far, right? So what if this represents standard deviations from the mean? So $45,000 is negative 1.5 standard deviations from the mean. 57, negative 0.92 standard deviations from the mean. Now, what's the closest number to $75,000, our mean? What's the closest data point?
78,000.
78,000. Now look how small that standard deviation is from the mean.
1/10.
All right. I got you though. So it's very small, but then as you start to go up, 88,000 is 0.62 standard deviations from the mean, 0.87, and then obviously 100,000 is a full standard deviation from the mean. It's going to be outside of that $19,000 difference from the mean. So that's why you have a full 1.2, and obviously you have a full $19,990 less when we're talking about $45,000. So it's just a really percentage value of what your standard deviation is.
Dr. Mon, I have a question.
Sure.
In between my first year and my Z first, there's another column, and I don't know how to delete it.
Oh, okay. So if you want to delete it, I think all you do is highlight the column, right click, and clear. Yeah, hit clear. Did that work for you?
Yes, sir. Thank you.
No problem. Okay. So that's real. So then we did this. So let's do a fun thing here. Now we remembered that our height, we did our height formula. And let's go back to our output and figure out what our mean is. I can't remember what our classroom height mean was. Each of you are going to calculate your own Z-score. All right, so let's find output. There it is. And we're going to scroll back up here to where we did our classroom heights. There it is. So the mean for our classroom heights was what, 68.5 inches, right? Cool. So what I'd like for you to do is to do your equation. So you're gonna have the very top. So if you were 71 inches, you're gonna do 71 inches minus the mean, which is 68.5. And you're going to divide that by the standard deviation, which is also in the output here at 2.63. You can stop at 63. And that'll tell you how many standard deviations you are plus or minus the mean. Once you've done that, drop it into the chat.
Drop our own, how far we are?
Your Z-score into the chat, yeah. That's how, Z-scores are very easy to calculate, by hand. I just wanted to show you how, where it was. Okay. So you're taller. You're almost one full standard deviation from the mean. Okay. So you're shorter than the mean, almost one standard deviation less. Thank you, Mrs. Hill.
Dr. Munn, explain that one more time.
Sure. Okay. So I'm actually going to, you mean the equation? The equation, yes, or the analysis? Okay, yeah. So what you're going to do, the raw score is your height, okay? And so what you're going to do is take your height and subtract it from the mean, which is 68.5 inches. That's the average height in the class, okay? But once you get that number, you're going to divide it by the standard deviation, which I believe was 2.63. And that's going to convert your raw score into a standardized z-score, or a representative of how many standard deviations you are from the mean. Now, if you were like 7 standard or heck, 4 or 5 standard deviations, if that number was 4 or 5, then that would show that you're extraordinarily much taller than your rest of your classmates. But for folk who are showing, negative 1.71, that tells me that you're shorter, but you're still within those 3 standard deviations of the mean.
Dr. Ma, I have a positive, and I know I'm shorter. So I took 68.5 and I subtracted 62.5.
You put your first one, you put your 62. You're 62 inches, right?
Yes, sir.
That goes first.
Okay, I wrote it down first and put it in the calculator wrong. Okay, thank you.
It's all good.
And Dr. Munn, I cheated. I ran the thing. I'm sorry. I didn't know you wanted us to do it on our calculators. I just ran the report.
It's okay. Sigmas are horrible people.
We're a resourceful people. So you told me how to run the report. That's what I'm going to do.
I got something that's crazy.
Okay, let's holla at
which is Fred. I got 52.9, but I know that ain't right.
Okay, so tell me, let's do this together here. What is your height in inches?
79.
You said, whoa, you're tall.
No, 69.
69. Okay,
that's the problem. That's the problem.
I know we haven't been together in a while, but I know you are not 79.
That's the problem. I figured it out. That's why I need class. That's why I need a class full of people to talk to. I be doing some crazy stuff where I'm by myself.
No, it's okay. Like, this is 69. So you hit 69 minus the mean, which is 68.5. And then you divide that by the standard deviation, which is 2.63.
0.19.
There you go. Yeah, so you're right there, under the 1 standard deviation of the mean. Cool. And so I'm going to do this real quick. Let's see. I'm going to do this right here. I'm going to do what Mr. Mathis did, which was to go to analyze the statistics, the descriptives. And so what he did was, which is very smart, he went in classroom heights. He saved the standardized scores. There we go. And then he pressed that out, and then he found his entry and was able to report. So this should be what we're seeing here. All right. So I see yours, Taryn. I see yours. Yeah. Yeah, I see yours. Yep, I see yours. You're 64 inches, LaShonda?
I'm trying to unmute. Yes, I am.
Okay, yeah. Okay, I see yours. Okay. Let's take a look at yours, Tina. It says that you're negative.
Dr. Mo, remember her height wasn't in there because she wasn't on at that point in time.
Oh, okay, bet. Oh, well, that's going to throw everything off then.
Yeah.
So
I'm sorry, guys.
No. It's okay. It's okay. It's no problem. It's okay. It's no problem. I was like, I'm going crazy here. Okay, we're cool. We're cool. All right. So that's Z scores. A fun way of representing another way of representing your standard deviations from the mean. Okay, it's really useful when you want to create a composite variable. And I'm going to explain what a composite variable is. Let me see here. Let's use bank loan data. Yeah. So what I'm going to do is bring up bank loan data. And I'm going to do this several times throughout the semester, creating composite variables. It's as a concept, it's a little hard to do to grasp the first time around. Let me see if I can find this data set here. So composite variables, as you see here, are things that you do when you want to create when there are variables that are similar, or you're trying to create a master variable to represent a certain thing or a certain data point. So what we see here on this slide is employment value. And employment value could be defined as salary, could be defined as education level and productivity. I think those are characteristics of employee value. Student size could be represented as height, wrist size, and weight. Now, obviously, if you were trying to combine these variables, there's a couple of ways that you can do it. The easiest way for me to show you how to do it is to basically turn each one of these variables. So salary would look something like $45,000 to $100,000, as I showed before. Education level could be 1 to 24 or whatever. And productivity could be some arbitrary interval data or hours worked, which would be then ratio, hours worked per week or hours whatever. But all those are different units, right? You know, all those, you have salary in dollars, you have education level in years, and then you have productivity in hours. And so to standardize all these data points, you could turn all of them into z-scores, and then you can combine them into one variable. And so to do that, what I'm going to do is I'm going to use this bank loan data set here. And so what I want to do is create from what I have here a variable that represents credit worthiness. So I'm going to create a variable that says credit worthiness. Okay. So let's write down credit worthiness on a piece of paper. And so I'm going to choose 3 variables here. I'm going to choose how long you've been employed. That tells me that, you know, you're pretty credit worthy. I'm going to choose income. That also tells me that you're pretty credit worthy. And then let's just say debt to income ratio or debt to income, whatever. All these are different values. This is year. These are represented in years or months or whatever. Doesn't really matter. This is represented in thousands of dollars, and this is represented as a ratio. But none of that matters. What I want to do is be able to see, I want to create a score for entry 1 all the way down to whatever. I want to figure out, you know, what the standard deviations from the mean are. So I'm going to change these into z-scores. So for employer, again, you don't have to master this today. This is sort of complex. I just want to show you how to do this. So we're going to go and to analyze, we're going to go to descriptive statistics, descriptives, and I'm going to do them all. I'm going to do them one by one. I'll do it one by one. So years with current employer. I'm going to click save as standardized values as variables.
You don't need anything with options?
No, you don't do anything. When you're making z-scores, you just click that box.
Okay.
And so you go over here to the end and it creates you a new variable, or it creates the new scores here, okay? So you're gonna go over here to income and you're gonna do the same thing. You're gonna descriptive statistics, descriptives, income in thousands, and just hit OK. And then, as I said before, the value will be right here. So you have Z income, Z employee, and then we're going. I think we said debt to income. So then we're going to go to the descriptive statistics, same thing, and descriptives. And then we're going to click debt to income ratio. And remember, this box is checked. Okay. All right, so now we have these values that now all of a sudden they were different in representation, but now they look pretty similar because now they're along the same sort of continuum. They're all standardized scores now. So what I want to do now is, again, create this variable called creditworthiness. So I'm going to go to transform. I'm going to go to compute variable. And I am going to create, I'm going to say, call this variable credit worthiness. If I misspelled it, forgive me. I'm not the best speller in the world. Okay. Now what I want to do now is click on years with current employer. We're going to go to the end to our new variable. I'm going to double click it, and then I'm going to hit plus. I'm going to double click this. I'm going to hit plus, and I'm going to double click that, and I click plus. And what I've done here, hope I'm doing this right, is I'm taking each of these variables and I'm adding them together, and I'm going to divide it by 3. And so essentially what I'm doing is I am getting the average or the mean and creating this new variable, okay? Okay, so what you see here, now that I've done that, what you see here at the end is credit worthiness. And what I have done is I've combined employment, years of employment, years of income, and debt to income ratio into
Dr.
one.
Mine is saying something curator.
Oh,
no spaces, Tina. You have to do underscores. I got the same thing.
you want me to go back?
So I put the underscore under the C.
You just, rather than doing credit space worthiness, do credit underscore worthiness.
Oh, okay.
Oh, that's sweet.
Okay, thank you.
No problem. So what you see here, so let's take a look at the first, let's take a look at our first entry here. Number 1, this person is 41 years old. They have some college. They have been employed with their employer for how many years?
17.
All right. Their income is what?
176,000.
And their debt to income ratio is what?
9.3.
9.3 thousand, or I guess 9,000. It's pretty good. Okay, it's not that high. So when we come over here, this person looks good. Before we even look at the variable that we've computed, this person looks pretty good. Would you lend to them? Just off of, this person has been at their job for a long time. That means they are earning great money. They've been there for 17 years. They're probably going to end up being there for a little bit longer. Their debt to income ratio is not horribly high, and they're making very, very good money. Okay. So they've paid their bill and they've gone to college, right? So they have some college experience. So this person on paper looks really good. And so my assumption is that taking a look at these data points, that this person would be pretty creditworthy, in my opinion. So as we go over here and we look at these Z-scores, we see that they are 1.2 standard deviations from the mean, so they're above. That means they're doing well. You can look at their income, and it is 3. It's actually more than 3 standard deviations from the mean, so it's almost an outlier. Okay, it's outside of that, outside that 99.7. And then you look at their debt to income ratio, and it is below the average. So that tells me, man, this person makes great money. In terms of money, they're making more money than almost everyone in this data set. They've been at their employer a very long time, and their debt to income ratio is less than the average. So what do we have in terms of credit worthiness? A good score here. We have a very good score in this variable that we have created.
Hey, Dr. Munn.
Yes, sir.
I did all of that and got all of that, but then my credit worthiness score is different than yours.
Okay. What did you get for credit worthiness for the first one?
4.56.
Ooh. Okay. So your Z scores, all these are the same?
Yeah, all of them are the same. 1.24.
I have what he have as well.
You have the 4 point. Okay. Let's go over here to transform and see here what we did. So you had, you put parentheses here?
No.
Okay. Put it, and I didn't specify that. Put a parentheses in front of employer, and then a parentheses at the end of debt to income, and then do the divide.
Okay.
And let me know if that kicks out. And you may want to, well, I guess it'll let you overwrite it.
Yeah, it surely did. Yeah.
It did.
Yep.
Perfect. And now you have, okay, good. Okay, great. Now, let's pick out another creditworthiness.
Now, before we go on to that, are we like, so is this, is like 0 the middle? And then so anything, okay.
Yeah, yeah, 0. The closer to 0 you are, the more average, So this person right here with a negative 0.04, they're right there in the middle. They're right there in the middle, But when you go over here and you see somebody who is a negative 0.7, they've got defaults here. Let's take a look at their education. It's probably, well, they actually have some in high school, but they've only been at their employer for 2 years. They've been at their address for 5 years. Their income is $16,000, and compared to other people, their debt to income ratio is pretty high. So they're not, in my opinion, just looking at it, they're not very creditworthy, and the math says the same thing. Now, I have two really. Here's one right here that is 2.03, and that's number 374 entry. This person did not complete high school, so it doesn't seem that there's much of a relationship between people who didn't complete high school and or education status and credit worthiness. And that's interesting. They've been at their employer for 14 years. They've been at their home address for 8 years. They make $72,000. Their debt to income ratio is pretty high. But their credit card debt is pretty high too. And they defaulted on their loan. I am shocked that they are creditworthy, that their creditworthiness score is 2.03. That is fascinating, because it should be the other way around, because they have a lot of risk factors here.
It's probably just because they pay their minimums on time every month.
But
It's not because they make good money or they ever pay anything off. They just pay the minimum every month. That's probably why.
But correct me if I'm wrong, but this variable doesn't take any of that into account. It only takes into account those three things we put in, which was years at employer, income, and debt to income ratio. Is that right?
That's correct. But no, it's fine. But I'm thinking that the other factors have some correlative value so I'm arguing that people are either creditworthy or not. And so even though I didn't put other debt or credit card debt in there, if you're a person who is making money and paying your bills, then those values going to have relationships on the ones that we did include in the model. Does that make sense?
No, it doesn't.
Okay, so although I did not put, although we did not put education level in the model, okay, we know that education is strongly related to income, right? So if that's the case, then what's going to happen is, even though we didn't put those other values in the model, I know that education and income are strongly correlated. And so if I take a look at income and education, those two are going to be very close. And so basically I can make assumptions that based on these other values, that they're going to be correlated with the other ones that we did include in the model. So we did include, I don't think there's any relationship with any of the other variables in employment, right? I do believe that there's a strong relationship between income and education. I also there's probably a relationship between years employed and income, because the longer if you've been employed at a place for 17, 18, 20 years, you're probably making, you're older and you're making more money. Obviously, there'll be a strong relationship between years employed and age, right? If you're 22 years old, you've not been employed that long. So you can make just, general connections between these variables, although you didn't include them into the creditworthiness variable.
I have a question.
I'm sorry. Was that Vonda? I'm sorry.
Go ahead.
I'm still not here.
Okay.
But I think I may see why for me because I understand that, but I'm also saying you're making assumptions based off of other things, and all SPSS is doing is what we told it to do, which is add these things together and take the average of them to figure out what the creditworthiness score is. I think also, and correct me if I'm wrong, if you, Dr. Munn, would go to line 374, go over to the Z-score for debt to income. Are we looking at that wrong? Because mine has that person's debt to income as a 4.64, which is highly outside of normal 3. So
wait, yeah.
So it's what's taking their score up, unless my stuff is just wrong.
You said
374.
374.
That's what we were looking at, yeah.
All right. Their debt to income was 41. That's pretty high. And you said what? Yeah, that's four standard deviations. That tells us that their debt to income ratio is much higher. If we're looking at this right now, I'm assuming that the higher your debt to income ratio number is, that means the more debt you have relative to your income. That's my guess here.
So almost.
But I thought with the higher debt to income ratio, people shouldn't lend to you because your debt is so high. But I'm with Maurice now; they have a 2.
Yeah,
so
they have 2.
Like it needs to be. It's almost like that Z-score for debt to income needs to be converted. Like it needs to, you need to change the direction. I don't know how to say this, but like that 4.6 really should be a negative 4.6 because it's a negative thing for that to be so high, but it's offsetting everything else because it's acting as a positive number.
Yeah, you're absolutely right. By looking at now, full disclosure, I could be looking at this wrong. 41.3 may be great in terms of debt to income ratio. I don't think so.
Debt to income, so
yeah, I'm thinking that 40 because this is in hundreds or something. Was it in hundreds? Let's go to variable view here. Debt to income. Yeah, it was times 100. So you add you add 2 zeros to it. So to be quite honest, I'm not sure how to read this variable. And you're absolutely right. It had an incredible impact on the Z-score here. It basically made this person very creditworthy, where it may not be creditworthy whatsoever. That's an incredible observation. Again, I'm not sure I'm not a bank loan person. I'm not sure. I'm going to be honest. I'm not sure how to read that. But yes, you're absolutely right. Since that standard deviation, since you're reading that 4.6 standard deviations from the mean, it is absolutely taking him and making him look incredibly creditworthy. And every other indicator, as you said, seems in the, let's see, what else do we have in that one? They have defaulted. They have a lot of other debt. And it makes it, yeah. So my opinion, this person has a ton of other. We can just look. Now this is straightforward. They have 15,000 and yeah, they have $15,000 in credit card debt. They have $14,000 in other debt, and they're only earning. So I wouldn't. And they have been at their employer for a long time. But yeah, based on how we're measuring this is.
You just need to make that a negative number.
Yeah, actually, what I'm gonna do real quick, I think I'm just going to delete that. Let's do this. And I'm probably spending too much time on this, but no. I love it because it's helping me get this stuff right. So if we are not sure that debt to income ratio is the best measure here, we know credit card debt is a straightforward measure. Right. We know that is, right? That's 15,000 in credit card debt, and that's never going to look good, right? So let's do this. Let's take out, let's go ahead and create a Z-score for credit card debt. But I wonder if it's, so it's reading the higher the value. Okay, we can't do that. We can't use that. Do you understand why? Because it's reading the higher the value, it's treating it as a better.
Right.
Yeah. We can't use that. We can't use that at all. Okay.
Now SPSS needs a way where you can be like, okay, yes, we understand that the more, it just needs to be negative.
Yeah. It needs to flip that bad boy. Yeah. Thank you. So I guess the best thing to do here is if it's positive facing in a situation. So the more years, the better. The more income, the better. Let's just do that, and let's see how that changes things. Yeah, this is fun. Okay.
Well, I wouldn't say fun, but all right.
All right. So let's go back to transform. Let's go to compute variable. Let's highlight this in the plus sign and take that out. And let's put a parentheses here, and let's put 2. Obviously, we have 2.
variables.
Yeah, 2 variables. We're going to underscore that and put creditworthy underscore 2. So we're going to create an entirely new variable. And now we're going to click OK. And we should have something very interesting at the end now. Yep. So let's go back to that 374 guy. Because now I'm very interested to see.
Wow, yeah, he's not looking as good anymore.
It's interesting though. He's not negative though. Like they're not counting him out. Like you look at that score and like, he's not terrible. He's not, 365, which is a full standard deviation under the mean. Interesting. But that's a very astute observation. Thank you for that clarification. We were treating debt, the income, as a positive thing, and that's not what we want to do if we're evaluating this as a composite variable. Hey kiddo, how you doing?
But surely there's a way to just flip it and make it negative so that you can evaluate it accordingly.
Right, and it's probably I will research that, and I will have a way to do that. What card? Which card? Oh, here you go. Oh, yeah, you used it for work. Yep, sorry. Okay. Oh, sorry. Yeah, I will research that and get back with you. I'm sure you're right. There's a way. Obviously, I think multiplying everything by -1 is probably because if it's already negative, it will turn to a positive. Yeah,
which you I guess could probably do.
It's easier to do in Excel.
Or could you in SPSS? Could you just go up to transform and just do that? Can you just times it by -1?
Yeah, I think you probably could. Let's see here.
I'm giving you a whole bunch of extra stuff, and I'm actually about to exit class because I have an engagement. I do want to see if you can do this right quick.
Yeah, let's see. The income. Do I? What if I do another parentheses? I don't want everything else to.
I think you have to do another parentheses only because of order of operation.
Okay, math teacher.
I see you. All righty. Let's see how this works. This thing gonna blow up on me. SPSS isn't like anything wrong. Yeah, I got a weird thing here. Change existing. Oh yeah, okay. You're gonna change existing variable. That works. It's going to give us something. I'm not sure if it's what we want. All right, let's go back to 374.
Mm-hmm.
Let's see what this looks like now. Nah, it's still wilding. It's still high.
But I guess I was trying to say make.
Hold on. Was that 2? Yeah, no, it did. It worked.
Did it work?
Negative, yeah.
Oh yeah.
Yeah, I was looking at the wrong one. It worked. Yeah, absolutely.
Dr. Ron, can you show us your formula so that we can put it in our...
Sure, yeah. So what I did was I just put another parentheses in here. I did the star, the multiplication, -1, and parentheses. Yep.
Okay.
Yo, thank you all. See, that taught me something today. Yeah. And that absolutely works. Okay. We have 19 minutes, and I really want to, I really enjoyed that. That was fun. I probably spent way more time than I intended to. I want to get into crosstabs just quickly. Okay. So crosstabs really is a summarizing way or way to summarize two categorical variables. All right. Take care, Maurice. And so we're leaving continuous because with standard deviation and measures of dispersion, we were dealing with strictly continuous variables. But now we're going back to categorical variables. And so you see the picture up there in the top right-hand corner is just basically a count. That's all that crosstabs do. And you could also add a version in here when you're just looking at where you also have percentages. So what we're going to do quickly is take a look at SPSS workflow data set for good old college students. And what we want to do is summarize the variables by each other. All right. So what we're going to do is take a look at gender and athlete. Okay. So let's pull up our college student data set here. And we're going to go to analyze, and we're going to go to a different one this time. We're going to go to descriptive statistics, and then we're going to go to crosstabs. Once we're there, we're going to look over here. We're going to make sure that we're picking a categorical variable. And in this case, this is a nominal variable. So we're going to do gender, and we're going to do whether or not they were an athlete. We're going to put gender in a row, and then we're going to put athlete in the column. We're not going to run any statistics because we're not answering any questions. We're just taking a look at the numbers here. We're going to click Display Clustered Bar Charts. And then we're going to click OK. You know what it did? Is that doing that again?
Mine showed there were 426 participants.
Yeah, mine is giving me a hard time again. I did this last night when I tested it out. Okay. All righty. Not to worry. I'm gonna have to you guys see what's going on, right? Who got the participants? All right. I would like, if I have your permission, to share your screen. Is that fine? Who wants to share their screen?
I'll share mine.
Oh, go ahead, Fred.
No, you go ahead, Tina.
Because my SPSS.
I'm probably wrong anyway, but go ahead, Tina.
No one's wrong. We're just learning here. My SPSS is crashing, so I have to restart it. I don't know why I have such problems with it on this computer.
Okay, so I could just click share screen.
You got it, ma'am.
Do you guys see it?
Mm-hmm.
Yes, there it is. There it is. There it is.
I got it.
Yes, that's right. So basically, what we wanted to see was the just to break down an athlete. So, how many non-athlete males do we have?
103.
103. Okay. And how many athlete females do we have?
79.
All right. How many total females do we have?
222.
Mm-hmm. So we have more females than males. You could probably write up a couple of paragraphs or a paragraph just sort of describing these data. Okay. I'm going to try to fire up SPSS again. May or may not work. Thank you very much. That is excellent. Let's do smoking. So we want to see if Ms. Mitchell, if you don't mind going to analyze.
Oh wait, that's the wrong one. Sorry, guys.
No, you're fine. You're fine.
Okay. So you said go to analyze?
Mm-hmm.
I can't see it. Okay, analyze.
Mm-hmm.
I'm there.
Okay. I don't see it.
You want me to go to descriptive and then crosstab?
Yeah. Is anyone else seeing? I'm still seeing your output screen.
So am I. I don't see her other screen either.
Yeah, I don't see your other screen.
Well,
And you got to close that screen right there. Push it down so we can go back to the other one.
Don't worry about it. I think I have my screen back up. I hope. So yeah, let me stop your sharing real quick. And we're gonna try to share my screen again. And we'll walk through this together. You sound like you were on the right path though, so.
I see it.
All right.
Can you see it now?
Yes, okay, yep. So gonna analyze.
Oh, something's going on. It's beeping. Sorry, guys.
It's all right. It's okay. Let me take control back. But thank you for doing that. Let me, just because I want to get through get through this point real quick. So yeah, so what we're going to do is take a look at, we're going to go to analyze here. We're going to go to descriptive statistics. We're going to go to crosstabs. And then we're going to put, we believe is a relationship between gender and smoking habits, right? So before we actually ask the question with SPSS, is there really a relationship between the two? We're going to see what the numbers say, okay? So we're just going to click display cluster bar charts, boom, boom, boom. And this time my SPSS did not fail me, okay? All right, so cool. What we have here in the row column is gender. You see gender here, and you see male, female. All right, so how many males have been past smokers?
13.
How many males are non-smokers?
149.
149, yeah. And how many females responded to that question?
209.
209.
Is there any way to make it bigger? I can't read the numbers.
Sure. Let me see here. Yeah, it did get small for some reason. Let me see if I can change. Huh. Oh, let me.
If not, it's okay. I just won't be answering.
Tanya, if you go to the top on your view options, you can turn it to 100% and then play with the size.
Gotcha. Thank you.
The joys of anyway. Thank you for that. Cool. So
Perfect. Thank you, LaShonda.
in our last 8 minutes, what I'm going to do is ask the question. So we're going to go down here to Chi Square. And Chi Square essentially, asks the question or answers the question: is there a relationship or association between these two categorical variables? And also answers the question: is that relationship statistically significant? So there can be a relationship. There can be a relationship between UFO sightings and alcoholism, but unless there is a statistically significant relationship, it's not really real, right? So these are best when they're 2x2 tables. You have to have two categorical variables and two or more categories for each variable, okay? And generally you want a large sample size. Again, this chi-square of independence can only compare categorical variables. I cannot make comparisons between continuous variables or between one categorical variable and a continuous variable, okay? One example I like to use in terms of a hypothesis or research question is and generally when you create a hypothesis for chi-square, you normally state it in the null. And so you always say there's no relationship between these two variables that I'm very interested in, okay? But if the test comes back to tell you that there is a relationship between those two categorical variables that you're interested in, then you reject the null hypothesis and recognize that there is a relationship. If it is not statistically significant, then you're going to basically say you fail to reject the null hypothesis and you have to hold that null hypothesis into place. So this is just how it looks. So say you think there's no relationship between the race of a principal and African-American student achievement. This is one of my prior students' thoughts here. And so the race of this principal is your independent variable having an effect on student achievement. Both of them are what? Categorical variables. The race of the principal, you can make it dichotomous. You can make it white or non-white. And you can make African-American student achievement pass or fail. Again, another dichotomous, variable, categorical variable. The level of social consciousness influences African-American achievement. All right, so your unit of analysis are the schools. And so you categorize consciousness as being woke or not woke, or an African-American achievement, again, is pass or fail. So those are some basic, really, really basic, examples of two categorical variables and wondering if there's a relationship between the two. We'll go into much more detail on this next week. But essentially, there's a thing called the p-value or level of significance. And the way I was taught was generally that's the first thing you look at. If you can have all these pretty numbers that tell you that there's a strong relationship, a strong positive and negative relationship, but unless the p-value tells you that the outcomes are statistically significant, it means absolutely nothing. So generally, what I look at is the p-value or the significance value. And if it's 0.05 or 0.50, what it's telling you is that, or 0.05, it tells you that if this study were given 100 times, that we should expect the same results 95 times out of 100. Only 5 times would we expect for the results to differ. Sometimes you see your significance level being less than that. Sometimes it's higher than that, but when it's less than that, then it's a pretty strong significance level, and you can go with the results. And so we'll get into that in much deeper detail next week. So again, as I said before, you examine the significance level. Significance level is less or equal to 0.050. There's a significant relationship between the variables. And the effect size is something else that we'll get into next week. That'll depend how strong the effect is. If there is a significance level, then you reject the null hypothesis and state that there is a relationship between those variables. And if the significance level is greater than 0.50, you state that you will fail to reject the null hypothesis. Probably too close. Well, I guess I can do this real quick. You don't have to follow along. As I said, I will be going into much greater detail next week on this. And so, there it is. So the same variables, we want to see if there is a relationship between, so there's a relationship between whether a person is an athlete and smoking. So we want to see if there's a relationship between those two. So what we're going to do, we're going to go to analyze descriptive statistics and crosstabs. Same thing we did before. And so I think that athletic status at this college has impact on what has a relationship with whether or not people smoke or not, right? You would think that as well. I don't think we have a lot of track players running around here smoking cigars. So what we're going to do, we're going to unclick the bar charts for now. And we're going to go to statistics, and we're going to click Chi Square. And Chi Square, again, is the test of independence or relationship between two categorical variables. And since these are nominal variables, we're going to click phi and Kramer's V to tell us what the effect size is. And again, I'm going to go over all this again, just giving you a quick run through here. Then we're going to click continue. And then we're going to go to cells. Now, the observed is what the test tells you is actually going to come from the interaction of these variables. And expected is what we would expect if there was no relationship between the two variables. If these two numbers are about the same, then there's generally no relationship between the variables. But if observed has, some significant difference, then we can tell that there is a relationship, okay? So I'm gonna click continue, and then I'm going to click okay. So right from the bat, you see this cross tabulation that looks very similar, but then you see this count observed and you see this expected count, okay? Now, again, expected says that this is what I would expect if there was no relationship between athletes and non-smokers. And we clearly see a difference here with non-athlete. We see a difference here between past smoker and current smoker. And we see a difference here between athlete, non-smoker. We see a difference here with smoking, and we see a difference here with current smoker. Okay, now remember I said the p-value is incredibly important, very, very, very important. And it had to be below a 0.05 or less, right? What do we have here? 0.000. So what that tells me is that at least if we do this test at least 1,000 times, we're going to get the same result, 999 times. So this is a very, very strong model. And we have a 0.2 effect size. And if you turn to page 102 in your Morgan, it will give you, we'll go through effect sizes next week. But our initial question was, or our hypothesis was that our null hypothesis was there is no relationship between athlete status and smoking status. And what we see here is not only are the expected counts and observed counts different, we see here where the significance level proves that they are, this model is statistically significant. And so we can say we reject the null hypothesis and we accept the fact that there is a relationship between athletes and smoking status, which makes sense, right? You know, again, you're not going to be out here running the 100-meter dash and smoking a cigarette before. It just doesn't make sense. Okay. It is 11:52. Thank you so much for allowing me to go over. I will be publishing this as a YouTube video. We will be going back over this again in much greater detail next week. I hope this has been helpful. And yeah, anybody have any comments, feedback? We're getting into the good stuff now. We're getting to the place where we can start answering and asking questions, and that's where it starts to get powerful.
Good stuff. What? Fun, good stuff for you because it's already in your brain. But I do appreciate your very explicit directions and style of teaching. Thank you.
Well, thank you for that. And I wanted to get into all of your brains. So ask me as many questions, stop me as much as you need for me to stop you, stop me as much. And you saw how I learned something today from you all, and I appreciate that. This is statistics is so broad, so large, and you're always learning how to do things differently. So thank you for that. See you next week. Next week we have a video discussion board. I will get that up today, probably closer to later to 11 o'clock. And we have chapter 8 in Morgan. And yeah, the video discussion board. Thank you all so much. Thank you for your hard work. Have a great weekend, and I'll see you all next week.
Thank you.
Thank you. Take care. Bye-bye.
Bye.